Good evening everyone, I am Mr. Ish. Thank you for joining me for this video. We are looking here at a topic of trigonometric integration. We have already discussed basic trigonometric integrals, and as we get into more of this trigonometric integration, let's just look at this one single example and use that for our theme for this video, a smarter way to integrate. At first glance, one would be tempted to use polynomial substitution technique, but it would kind of fail. The reason being because these two functions are not next to one another. Because of their quotient relationship, you couldn't really get away with it. You would normally do u is equal to sine x, and then you do du is equal to cosine x dx, and then dx is equal to du over cosine x. And the reason why we did u is equal to sine x, because that represents a sort of a composite function here. You would do u square and then du over cosine x, and you have this original cosine x, but you can see these things don't cancel out. So this technique kind of stops before it even lifts off. So what exactly do I mean when I say a smarter way to integrate? It's not like meant as an insult by any means. It just means that you have to use good judgment over here when it comes to integrating, especially when we're talking about trigonometric functions. The reason being, this could be handled in several ways, and I'll show you two ways. One way is considered the smarter way of doing it because it's very easy. The other way, you'll take it through the longer way and you'll still get to the same end result. Remember, if you can do an integration or a derivation procedure or a derivative question a quicker, easier way, that's a smarter way because you're doing it in a time efficient manner. The smarter ways will normally require that you recognize hidden trigonometric identities or some useful hidden trigonometric techniques that you can bring to light. And sometimes those hidden elements are so well hidden, but when you recognize them, the question becomes drastically very easy. Let me show you this using the easy way, the quick way. If you were to consider bringing this cosine up, and based on the videos you know so far, the basic integral and the polynomial integration substitution videos, you should be able to do it using the smart way with what I've shown so far. The other way, the harder way, I'll show you a technique which we've not even talked about, but I'm only going to show you for the means of this topic. That's it. We'll talk about that in a future video when we learn that technique. But the smarter, easier way, you can do it if you think about trigonometric identities. If you were to rewrite this as sine square x and then secant x, because you recognize cosine x reciprocal is a secant x. And then you think back to the Pythagorean trigonometric identity, which involves sine square x plus cosine square x equals 1. If you substitute over here 1 minus cosine square x, which is the same as sine square x, and you bring in the substitution, your question will become very easy and you'll see it. All you have to do here is open up the parentheses, multiply secant x with this and with that, and open it up. You'll have secant x minus cosine square x secant x. Remember, this right here is a smarter way because it's an easier way, quicker way. You can even simplify this. Secant x minus, this will just become a cosine x because one element of cosine x is eliminated by the secant x, and that's all what comes into play. When you do the integration of this, you know it now because we've talked about basic trigonometric integrals and we're literally one step away from finishing it, and our answer over here is the integral of secant x is natural log secant x plus tan x minus the integral of cosine x is generally a positive sine x, but here with the minus we get a minus sine x plus c, and this right here would be your correct answer. And it's an easy, smart way to integrate because we recognize this could be brought up as secant x. This right here could be replaced with this trigonometric identity, and the question became very easy. Now let me show you the harder way of doing it, and there's nothing wrong with it, it's just the harder way, and you would require a more difficult technique to manage it. Now to handle the same integration for this function over here using a different technique requires you to know integrating by parts. V minus integral v du is equal to integral of u dv. Now the same question can be handled this other method. It requires you to know integrating by parts technique. uv minus integral v du is equal to integral of u dv. If that represents my integral u dv, then we can use this template over here to manage that. But as I'm telling you, we haven't talked about this, we haven't learned this, but when you do learn it, you can challenge this question using this way, but this way is the harder way and more complex. But we'll show it to you anyways, because again, we're talking about a smarter way. The smarter way is usually the easier, quicker, more efficient way, with the hidden elements and you being able to bring in trigonometric identities to make your original rational function easier. What can we do over there with that question? This is what we can do. You can do sine x over cosine x times sine x dx. I've just separated one element of that sine x with the cosine x. This is exactly equivalent to that. Now I suddenly have tan x sine x dx, and now we can do integrating by parts. This technique for some function which looks like that. And you will learn it, but I'm just showing you over here. You have to do a certain set of smart substitutions. If u is equal to, let's say, tan x, then du is equal to the derivative of that, secant square x dx. And v, these are the elements you have to find when you're doing these integrating by parts technique. You have to look for a u, a du, and a v. V is equal to integral of what remains, the sine x. And that is here minus cosine x. Then once you have these v values, du value and u value, you bring them right here into this part. uv minus integral v du. Remember, we will show you this in a future video because this is still an essential technique to know. U was tan x. See, uv minus integral of v du is equal to this, which is same as that. U times v, which is minus cosine x, minus integral of v du. V over here is minus cosine x. So don't get intimidated now. We have to learn it, and it's not too hard. We'll even learn how this formula is derived. V du. Du is right here. Secant square x dx. You can solve some of this. Minus cosine x tan x is what comes out here. This minus and this minus becomes a positive. This cosine x with this secant square x can be negated such that you end up here with just a secant x dx. See, cosine x times one of its reciprocals goes away. You're just left with a secant x because that was to the power of 2. Now this right here is very easy to integrate, and this right here minus cosine x and tan x can actually be simplified because tan x is made up of sine x over cosine x. That cosine x can cancel out with that. You end up with having a minus sine x come down from right over here. Plus, what's the integral or the antiderivative of secant x? It's a natural log. Secant x plus tan x plus c, and that's exactly what we had arrive in the previous technique, the technique that I dubbed as being the smarter technique because it was more easy, it was more efficient, and it was time saving technique. This is a harder technique, but it's not a wrong technique, and there are multiple ways of doing the same question, but you always have to in your head try to aim for the easier, smarter way, because one of the main advantages of that is that it reduces levels of frustration as you're doing integration. Anyhow, that's all I wanted to show you in this video, is using that simple and single question, how we can do it in two ways. And always in your minds try to aim for questions especially involving trigonometric functions. Try to do it the smarter way, which employs the use of trigonometric identities. I hope you enjoyed this video. Thank you for watching. Have a nice day.